Hello, in this video we will see insert and delete functions of the binary search tree. But before starting these functions, we will first of all see what is the meaning of the binary search tree. This is one of the example of the binary search tree. Within this, if you observe the 8 is connected to the two nodes. This 3 is called as a left child of the 8 and 10 is called as a right child of the 8. And 8 is a parent of 3 and 10. Like that, suppose if you observe the 1 is not connected to the any element, it means 1 do not have a child. So because of that, 1 is called as a leaf node. Same for the 4, 7, 13. These are the leaf nodes. Now if you observe about the 14 only have a left child and 14 is a parent of the 13. Now first rule of the binary search tree is you can connect maximum 2 elements to one parent. Means one parent can have a maximum 2 children. Now in case of the 8, you cannot connect the third element to the 8. This is the first rule of the binary search tree. Another rule is if you take this 8 as a parent, the value of the left child must be less than 8 and value of the right child must be greater than 8. That is the second rule. Now if you observe all the nodes which are present into this tree, they are following both the rules. I will just pick up the 6. If you observe the 6, the value of the left child 4 is less than 6 and value of the right child, that is a 7, it is a greater than 6. So they are following, all the nodes are following this rule. So because of that, I will say that this is an example of the binary search tree. Next is how can I add and delete the elements from the binary search tree. Let's start with the first function, insert function of the binary search tree. This is a binary search tree and I want to add the 11 value into this tree. So first task is find out the proper place of the 11 so that after adding this 11, still it will remain the binary search tree. The rule of the binary search tree is you can connect the maximum 2 children to parent and left has a smaller value than the parent and right has a greater value than the parent. In the binary search tree, there is one specialized node, it is called as a root. From the root, you can fetch the remaining values of the binary search tree. You cannot directly jump to the any element of the tree. You always have to start from the root. So to add the 11, first of all, you have to compare the 11 with the 8. Now I found that 11 is a greater than 8. So you have to place the 11 to the right side of the 8. Now there is some element to the right side. So next task is you have to compare the 11 with the 10. Now after comparison, I get to know that 11 is a greater than 10. So again I will move forward to right side of the 10. Now next we will compare the 11 with the 14. Now 11 is a smaller than 14, so we will add the 11 to the left side of the 14, but there is a one already 11 present to the left. So we will compare the 11 with the 13. Now here 11 is smaller than 13, so we will move towards the left of the 13. But there is no any element to the left of 13. So this is a right place where I need to add the 11. So 11 will be added to the left side of the 13. I will take one more example. Consider I want to add the 9 value into this binary search tree. So first of all, we will compare 9 with the 8. As it is a greater, so move towards the right side of the 8. Now we will compare 9 and 10. Now here I found that 9 is a smaller than 10. So you have to move towards the left side of the 10. But there is no any element to the left. So I will add the 9 to the left of the 10. This is the right place of the 9. So like that you can add the one node into the binary search tree. Now next we will see how we can implement the insert operation of the binary search tree into the C language. For this, you have to follow the 4 steps. Step number 1 is create a new node. Under this, you have to allocate the memory for the new node. Step number 2 is check the root status. If root is null, it means your tree is empty. So newly created node will become a root. Consider there are some elements in your binary search tree. In that case, I will go for the step number 3. Under this step, I will compare the value of the new node with the tree elements, and if the value is greater, then I will move towards the right side. If value is smaller, then I will move towards the left side. Like that, I will try to find out the proper location of the new node. And step number 4 is, once you get that proper location, add that element to that particular location. It means, suppose I try to move towards the left side but left is null, it means this is a proper location of your new node. This is the way I can add the element. Before creating the new node, first understand the linked list representation of the binary search tree. Binary search tree is a collection of nodes, and each node has 3 parts: left, data and right part. Left part stores the address of left child, right part stores the address of right child, and data contains the actual value of that node. To represent such a type of node, in the C language you have to write down this code. Struct node, int data, which stores the actual value of the node, and 2 pointers left and right. It assigns or it points to the another node of the tree. So because of that, data type is a struct node. Now initially the root will be null. It means there is no any element in your tree. So you have to declare one pointer root and set it to the null, as there is no any element into the tree. Now next we will see how can I allocate the memory for the new node. Whenever you call to the insert function, your first task is allocate the memory for the new node so that it will store the value which you want to add into the tree. And after that, second step is find out the proper location so that I can attach that new node into the tree. So how can I declare such a type of new node? You have to use the data type struct node, as it is a pointer which will point to the newly allocated memory. Step number 2 is allocate the memory. So to allocate the memory, you have to use the malloc function. For the malloc function, you have to pass one parameter, how many bytes you want to allocate. Here we have used the size of operator. So here in short you are saying that how much byte require for the struct node, allocate that much byte. So malloc returns the void pointer. So you have to convert that pointer into the struct node. So because of that, you have to write down this line. Once you allocate the memory, it will create this such a type of node which has 3 parts. So our step number 2 is initialize the pointer. So initialize the pointer means you have to store the null value into the both the pointers. So how can I do that? You have to say that in the new node there are the 3 parts. So in the new node, just points to the left and set the null value at that location. It means I want the left part of this new node and store the null value at that location. Next is in the right part, new node points to right is equal to null. Means in the right part also stores the null value. Next thing is I have to set the data part. So this data part you have to take from the user. So for that I will use the printf statement. So this message will be printed and you are going to store that data into the data part of the new node. So you have to write down new node points to data, so that whatever the value entered by user, that going to be stored into this data part. Now we have created the new node and as well as we have set the data and left and right pointers of the new node. Now next task is attach that new node into the tree. When you want to attach this new node into the tree, there will be the 2 cases. First is tree is empty and second case is tree is not empty. So we will see these both the cases one by one. We will start with the case number 1. Under this case number 1, first of all we have to check whether your tree is empty or not. So how to check tree is empty? If root is null, that time I will say that my tree is empty. Consider your tree is empty, it means your root will be null. It is not pointing to anyone. Now you have created the one node. The name of this node or who is storing the address of that node, new node stores the address. So I will say that this newly created node will become a root as there is no any element. So how can I write such a things into the C language? For this, I will say that if root equal to null means compare the value of the root. If it is a null, then I will say that root equal to new node means make a new node as a root, and after that return to the calling function. So like that you can handle the case number 1. Now next we will see how we can handle the case number 2. It means if there are some elements present in your tree and I want to add one more element into the existing tree. So how can I do that? For this you have to follow these 3 steps. Step number 1 is compare the new value, and according to the value you have to decide in which direction you have to move, either left or right, depend upon the comparison. And suppose you are trying to move to the left side but there is no any path, it means left is null. That time you will get to know that this is a proper place where I have to add the new element. Means for example, in this tree I want to add the 50 value. So for this, first of all I will compare the 50 with the 20. 50 is the greatest, so I will move towards the right side. Again 50 and 45. 50 is a greater, so I will move towards the right side. 50 will be compared with the 67. Now it's a smaller than 67. So I will try to move towards the left side, but there is no any element to the left. It means it's a null. So this is a proper place where I have to add the 50 value into the tree. Next we will see how can I implement these 3 steps into the C language. So for that, first of all, take one more pointer, temp pointer, which is a pointing to the root node of your tree. As I said, you cannot directly jump to the any element of your tree. You always have to start from the root node. So for this, you have to write down the line temp equal to root. It means both are pointing to the same location, that is a root node of your tree. After that, we will compare the temp data and new node data. If it is smaller, then go to the left side, otherwise go to the right side. Now to do this task, you have to write down if statement. If new node data is smaller than temp data, then move towards the left. But while move towards the left, you have to check whether left is null or not. If it is a null, it means there is no any element, then this is the right place. You have to add the new node at that location and come out of the function. Otherwise move towards the left side. Same thing we will write down for the right side. If I move towards the right and it is a null, that time this is a proper location where you have to add the new node. Otherwise just and come out of the function, and otherwise move towards the right side. Now repeatedly we have to do this same task. So we have to enclose this into the while loop while temp is not null, and you have to do this same task. Now step by step I will show you how 50 will be added to the left side of the 67. As I said, the first of all temp will be initialized to the root. With the help of this line, the temp will be pointing to the root node. Now temp is not null, so they will enter into this while loop. Now they will compare this new node data, it's a 50, and 50 and 20 will be compared. Now this condition is false, so they will go into the else part. In the else, they will check the right of the temp. Now right of the temp is not null, so this condition is false, so they will move towards the right side of the temp. Now temp will go to the 45. Now 45 and 50 will be compared. So here it is a greater than this temp data, so they will go into the else part. Now they will check the right side of the temp. If it is a null, then we will add the 50 at this location, but right now it's not null, so we will just move towards the right side. So temp will be pointing to the 67. Again temp is not null, they will enter into the while loop. Now this temp data, that is a 67 and 50 going to be compared. Now this condition will be true because 50 is smaller than 67, so they will enter into this if. And after that we are checking the left side of the temp. Now left side of the temp is a null, so this condition is true. And what they said that temp left is a new node now. temp left right now null, so but we have creating this link, so temp left will become a new node. Who is become a left side of the temp? New node become a left side of the temp. So we have written temp left equal to new node, and we have added the new node successfully, so return from this function. So with the help of return, they will come out of the function and they place the new node into the tree. I just explained you the insert operation of the binary search tree. Now I will show you the execution of this insert operation. Here we have declared the struct node as I said in the explanation. After that, I said that you have to declare one more pointer, that is a root. It's a global pointer and it has to be set to the null initially. After that, write down the insert function. Within the insert function, you have to use these two variables. One is a new node and second one is a temp. So declare those variables. After that, allocate the memory for this new node and set left and right pointer to the null. After that, ask the user which data they want to add. Once you done that, as I said, there are the two cases when your tree is empty and when your tree is not empty. So first of all, check whether tree is empty or not. If it is empty, that time write down this, you can say your newly created node will become a root. Otherwise, with the help of this loop, you are going to find out what is the proper location of the new node. I have already explained all these codes. Let's check the execution of the code. Now they will display me the menu. I said that I want to add the element, enter value. I have added the 23. Initially your tree is empty, so 23 will become a root of your tree. After that, again I said that I want to add the element. I said that I want to add the 45. Now it will be added to the right side of your 23. After that, again I said I want to add the element 12. So this will be added to the left side of the 23 and I will call to the display function. So I will get to know that whether they have added these elements or not. If you observe that this 23 is a root and 12 is the left side and 45 is the right side of the 23. Next we will see the delete function of the binary search tree. Now let's look at the flowchart for the delete function in the binary search tree. This flowchart shows the main steps involved when we delete the element from the tree. First step is to check whether tree is empty or not. If root is null, it means there is no any element in the tree, so no deletion is possible. If the tree is not empty, it means there are some elements in your tree, so we have to move towards the step number 2. Now step number 2 is we check whether the node we want to delete is present in the tree or not. If the node is not present in the tree, we simply show message saying node is not present in the tree. Otherwise, we will move towards the step number 3. In step number 3, after locating the node, we need to determine what kind of node it is. There are the 3 possibilities. The node is leaf node. It means it do not have any children. Second case is the node has one child. It means it has either left or right child. Number 3 is the node has 2 children. Each of these cases is handled differently in the deletion algorithm. Now step by step I will explain you this code. First of all, whenever you call to the delete function, first of all check is there any element to delete into the tree. So if root is null, it means tree is empty, return to the calling function. Otherwise, ask the user which element they want to delete. That read that value into one of the variable. Consider user says I want to delete the 50, then value will become a 50. And these two are the initial settings you have to do. First of all, set parent equal to null and temp equal to root. So temp is pointing to the root node 20 and root do not have a parent, so parent will be set to the null. After that, if I want to delete this 50, then temp has to come here and parent has to be set to the 67. Once we done this initial settings, we have to write down one while loop. Under this while loop, we will actually find out whether this element is present into the tree or not. For this, we have to combine these two conditions. First of all, check temp is not equal to null. And if it is not null, it means then check the temp data. whether is equal to value which I want to delete. In this case, temp is a not null. So first condition is true. Second, I will say that temp data is not equal to value. Value is a 50 and temp data is a 20. So this condition is as well true. So they will enter into the while loop. After that, what we have written, parent equal to temp. Means the temp is a present at this location. So bring the parent as well to this location. So after completing this instruction, parent is as well pointing to this location. After that, what we have written, the value which I want to delete, is it smaller? Then we have to move towards the left side, because if it is a smaller, then I will get that element to the left side. And if it is a greater, then I will get that element to the right side. So if value of the temp data, if the value is a smaller than temp data, then temp equal to temp points to left. In this situation, this value 50 is greater than the 20. So they will enter into the else part and they will move the temp to the right side. So after completion of one iteration of the while loop, this will be your result. Parent will be pointing to the 20 and temp will be pointing to the 45. Again, we will enter into the while loop as temp is a not null and value is a temp data not equal to 50. So we will enter, and what we said that parent equal to temp means bring the parent at this location. After that, compare the temp data and value. Now value is a 50 and temp data is a 45. So this condition is false. They will go into the else part, and in the else part we said that move the temp to the right side. So after completion of second iteration, this is a result. Parent will be come at the 45 and temp will come at the 67. Again, temp is a not null. So we will check the temp data. Temp data is a 67 and value is a 50. Again, they are not equal. So I will enter into the while loop. First of all, bring the parent to this location with the help of this line. After that, we will check the value. Value is a 50 and temp data. Temp data is a 67. So this condition is true, that is a 50 is a smaller than 67, and we said that move the temp to the left side. So after completion of third iteration, this will be your result. Again, we will check the condition of while loop. Temp data not equal to null. It's not equal to null because it is pointing to one of the node. Check the temp data. Temp data is a 50 and value which I want to delete, it is also 50. So condition is false in this case because we are checking not equal. They will come out of this while loop. So this is a proper location of the temp and parent. So temp is a properly set to the element which I want to delete, and parent is a set also set to the 67. Consider if element is not present, that time temp will become a null. So you have to say that if temp equal to become a null, that time print this message element is not present into the tree. Once we got the element, we have to check whether it is either leaf node or the node which has a one child, either left or right, or the node has a two children, left as well as right. Consider case number 1. If the node is a leaf node, it means left and right both are null. How we can check it is a leaf node? If the temp left equal to null as well as temp right equal to null, it means this is a leaf node which I want to delete. Now this is a situation, if I want to delete the 50, it's a leaf node because left is also null and right is also null. Here as well, consider this is a situation, means the tree contains only one element. So 20 is a root and left is a null and right is as well null. So this is also a leaf node. Now if this is a situation, they will enter into this if. Now we have to handle this both the situation differently. So we will check if parent equal to null. As I said, we have to do the initial setting. Parent is a null and temp is a pointing to the first element of your tree, and the tree contains only one element. So this initial setting will be remain as it is. So if the parent is a null, it means you are deleting the parent of your tree and it contains only one node. So if there is a one node and you are deleting that node as well, so your tree will become a null. So how can I set the tree equal to null? That you need to write down root equal to null. This is the second situation. This is a second situation. I want to delete the 50. So while deleting this element, first of all you have to check whether it is a left element of the parent or right element of the parent. If it is a left element, then you have to set parent left to the null, otherwise parent right to the null. The element which I want to delete, it is a left child of the parent, then left has to become a null, otherwise right has to become a null. So you have set the pointers at proper location. Now next task is deallocate the memory which is allocated to the temp. So you have to use the free function, and with the help of that you can delete the memory which is allocated to the temp. Consider the second case in which the element has a one child, means either left or right child. In that case you require third one more pointer, that is a child pointer. If I want to delete this temp and it has a one child, that is a left child, so you have to set the child pointer to this one, and I already told you how to set the parent and temp pointer. So if you delete this temp, the right of the parent will become a child. So you have to break this link and create one link, that is a parent right equal to child. So let's see how we can do with the help of C program. First of all, check the temp has only one child. So to do this task, I will say either temp left not equal to null or temp right not equal to null. It means it has only one children. Then they will enter into this if, because this condition will become a true. After that, next thing is you have to set this child pointer. If temp left not equal to null, it means temp has a left child. Child will be left of the temp. So child will be left of the temp. It means child is present to the left side. Otherwise, I will say that child is right of the temp, means temp points to right. Like that you can set the child pointer. Break this link and create the new link. First of all, you have to check the element which I want to delete. It is a left of the parent or right of the parent. Now in this situation, the element I want to delete, it is a right side of the parent. Then you have to change the right side of the parent. You are not going to change anything to the left of the parent. So how we can do this? I will say that if the parent left equal to temp, the element which you want to delete, it is a present to the left, then parent left become a child. Otherwise, parent right will become a child. So in this situation, parent right, it is not a temp now, parent right will become a child. So this is the way you can create the link. Once you create the link, you can deallocate the memory. Consider another situation. It means the element which I want to delete, it is a root of your tree. This is a situation. Now temp is a root of the tree. Now parent of this temp will be null. When the parent is null, it means you want to delete the root of your tree. So I will say that if parent is equal to null, then how can I handle this situation? I want to delete this temp, means 10 is a root of your tree, and I want to delete this 10. Then who will become a next root of your tree? This child will become a root of your tree. So you have to write down root equal to child. So like that you can handle this situation if you want to delete the root of your tree and it has only one child. Now last case is if I want to delete the element which has two children. Consider I want to delete the 45. Now it has two children, left as well as right. So in this situation you require two more pointer, successor parent, and one more is a successor. But what is the meaning of the successor and how to find out the successor of the particular element? Consider I want to find out the successor of the 45. The leftmost child of the right subtree is called as a successor of that particular element. It means now 45 has two subtrees. This is a left subtree and this one is a right subtree. As I said, the successor means leftmost element of the right subtree. So I will move towards the right side. Now I will just find out the leftmost element. Now in 67 is not a leftmost element because there is some another element to the left side. Now here as well left is not null, so I will move towards the left side. Now here if I try to move towards the left side, left is a null. So 48 is a successor of the 45. So you have to set the successor pointer to the 48 and successor parent to the 50. But how can I do this task? For this, we have to write down this code, and initially you have to set the successor parent to the temp, and this means successor parent will be present at this location and successor will be temp right, means this will be your successor. This will be the initial setting. Once you done this, this will be your resultant status of your pointers. Successor parent will be present here and this is a successor. Now as I said, you have to move towards the leftmost element, so I will move towards the left side of this 67. Here we have to write down the while loop. As I said, you have to go to the leftmost element. So if the successor left is a not null, now in this case it's a not null. So what we said, first of all bring the parent here, then move the successor to the next location. So successor parent will be successor. So this pointer will come here and after that you will move this pointer to the next location. So this will be your result. Parent will come here and this will come here. After that again we will check, is there any element to the left side? Then again they will enter into the while loop and they will again change this both the pointers. So in this case successor parent first we will bring here and then we will move this pointer to the 48 with this for loop. Now this will be your result. After that again we will come here in the while loop, we will check the left of the successor. Now in this situation it's a null, so we will stop at this location. Now this is the way we can set it properly. Once you just set these two pointers properly, next task is you have to copy the whatever the data present into this successor into the temp data. So how we can copy the data of this successor into the temp data? We will say that now temp data has to be update. So temp data is equal to successor data. So whatever present into the data part of the successor, copy that value into the data part of the temp. So after this both element contains the 48. Now our next task is to delete this successor. But before deleting this, first of all you have to check whether it is a present to the left or right side. If it is a present to the left, left has to be changed, otherwise right of the successor parent going to be changed. But what will be the left side of the successor parent? Whatever present to the right side of the successor, that will become a left of the parent. Why? Because as I said, successor is a leftmost element, so it's confirmed that there is no any element to the left side of the successor. But we cannot say anything about the right side. Right now it's a null, but there can be some element to the right side. So what we have to say? So what we will say, successor parent left will be whatever present to the right side of the successor. So for this, first of all we will check successor parent left is a successor. It means this is a present to the left side. Then the successor parent left has to be changed and it will become a successor right. Otherwise successor parent right going to be changed and it will become a right of the successor. And after that now you can free the whatever the memory allocated for this successor with the help of free function. This is a way we can delete the element which has a 2 children. In the C we will write down this delete function. Within this we will declare the required variables. If the tree is empty we will display the message, otherwise we will ask the user which element they want to delete and that value going to be stored into this variable. Next, these two things we have to done. Already I have explained all those things. Here we have written the code to find out that element. Consider this element is not present, then they will display the message. If the element is present into the tree and this is the leaf node, it means it has a left is null as well as right is null, then we will handle that case. Consider if the element has one child, means either left is not null or right is not null, then we will handle that case in this else if the node has a 2 children, then here we have handled those things. Like that we can write down the code, explain you how to write down the insert and delete function. Now next is how to call those functions. If you call the function, then only the instructions which are written into the function going to be executed. First of all, display the menu to the user. Next, take a choice from the user. Whatever choice entered by user depend upon that call to the particular function. And when user says I want to exit the code, then only come out of the code. Otherwise, again display the menu, take a choice from the user and call to the particular function. Now, how to do this task? First of all, with the help of printf, display the menu to the user. Next, take a choice from the user and read that choice into the ch variable. And depend upon the ch, switch or execute the particular case. So we will write down switch based upon ch. If case number 1 means if user want to add the element, call to the insert function, otherwise call to the delete function. If case is a 3, then call to the display function. There are the 3 ways I can display the elements of the tree: in order, pre-order, post-order. Whenever you display the elements of the binary search tree in the in order, the all elements are in the sorted order. I will post another video of how to display the elements of the binary search tree with the help of in order, pre-order and post-order. Now case number 4 is they want to exit the code, otherwise display the message like invalid choice, and I want to display this menu again, so you have to put that into the infinite looping. So we have written while one, and under this we have enclosed all this code. So this is the way I can call to the particular function. I hope you understand how to insert and delete the value from the binary search tree. Thanks for watching my video. Thank you.